Hey guys, Mr. Jenkins here with kind of the first part of Chapter 6. This is not an official kind of lesson in Chapter 6, but more of a review of some laws of exponents or properties of exponents that'll be helpful throughout the chapter. So that's why we're covering it. And then there will be like kind of a pencil paper type of assignment at the end. So no Math Excel that goes with this. All right, so with that, we will just get right to it. There's lots of rules and whatnot, and if you don't get it all today, we'll be covering it, kind of throughout the chapter as well. All right, so our first rule that we are going to go over is the product of powers. All right, so what happens when we multiply powers that have the same base? Is what we're looking at, right? So as we can see here, if we take x to the m times x to the n, that is equivalent to x to the m plus n. All right, so in other words, if we multiply like powers, we add the exponents, okay? So with this, I almost think of this as like terms, so the 5 and the 4, kind of, that's our coefficient, whatever 5 times 4 is, and then the other part is just the, x to the 7 times x to the 6, right? But we know that that's equivalent to x to the 7 plus 6. So altogether, that's going to be equal to 20x to the 13th. And then there's no other thing you can do to simplify that. So that would be kind of our final answer there. So I'll just pick one more of these to do. Let's look at maybe C. So coefficients, we'll kind of group those together and think about those as almost like terms. The C part, we have C to the 1 times C to the 2. So that'd be C 1 plus 2. And then lastly, we have that D term. So D, pick a different color there. So we have d to the 5 times d to the 2, so that's d to the 5 plus 2. So altogether, our final product is going to be 30 c cubed d to the 7. All right, kind of moving on. Next rule is what happens if we take a power to a power. Okay, so if we take x to the m and raise that to the power of n, that's equivalent to x to the m times n. Okay, so start to look for a pattern as we kind of go through these. So if we take x to the 5th to the 9th power, that's going to be equivalent to x to the 5 times 9, just applying that rule directly here, or x to the 45th. All right, and then, looking at the next two, I guess I'll do B. So this is 2 cubed raised to the 3rd power, and then that's raised to the 2nd power. All right, so that would just be equivalent to 2 to the 3 times 2, which is 2 to the 9 times 2 is 18. And then we'll probably just leave that there. If you wanted to simplify further, that'd be 262,144, since we have a non-variable base. Obviously, that would be a calculator kind of thing there. Okay, moving on. Kind of running right through these because we've seen this stuff before. All right, so what if we take a power to a product? I think of this as almost like the distributive property. Basically, if we take the product of x times y and raise it all to the m power, that's equal to x to the m times y to the m. Okay, kind of like the distributive property. It's almost like you distribute the exponent. You have y to the m, you have x to the m. Okay, so in the parentheses here, I almost think of this as 3 kind of separate powers. You have 2 to the 1, x to the 2, and y to the 1. All right, that's how you kind of have to think through these. So 2 to the, 1 time, not that you need to write 1 times 4, but just really breaking it down. We have x to the 2 times 4. Remember, power to a power, we multiply. And And then we have y to the 1 times 4. So we end up with 2 to the 4, x to the 8, y to the 4. All right, and then we'd want to simplify our coefficient. So 2 to the 4th is going to be 16. So most simplified answer is going to be 16, x to the 8, y to the 4. Okay, let's maybe do B. It's a little bit tougher. I'll go a little bit quicker through it. So if we raise everything in here to the second power, we get 3 squared, which is 9. Then we have g to the 3 times 2, that'd be g to the 6, and h to the 2 times 2 would be h to the 4. And then I'm raising everything in here to the third, so 2 to the third, I'll go ahead and simplify that to 8. G squared to the third, that's g to the 2 times 3, g to the 6. And then h squared to the third is going to be h to the 6. Okay, now applying a new rule. Now we're multiplying, right? So 9 times 8, that's just regular old 9 times 8, or 72. We have g to the 6 times g to the 6. All right, so now we got to keep our rule straight. So that wouldn't be g to the 6 times 6, that'd be g to the 6 plus 6, all right, or g to the 12. And then h to the 4 plus 6 would be h to the 10. All right, so those are 3 of the, I think, 6 rules we're covering. So we'll keep rolling along. So if we have x to the m divided by x to the n, that's equivalent to x to the m minus n, which makes a lot of sense. You know, if we multiply these two, we'd add the m and the n, right? So if we divide them, we subtract. Okay, so looking at A, apply that rule directly. X to the 9 over x to the 4 is equivalent to x to the 9 minus 4, or x to the 5. Okay, and then maybe look at B. So we'd have x to the 3 divided by x to the 1. That's x to the 3 minus 1. And then we have y to the 8 divided by y to the 2, or y to the 8 minus 2. So final answer is x squared times y to the 6. When you're right now, your answers, your final answers, if you have multiple variables, usually like a math book, an answer key is going to just go alphabetical order. But you know, if I had my answer written as y to the 6 x squared, that means the exact same thing. Because order doesn't matter with multiplication because it's commutative. Zero product property is just that anything to the power of 0 besides 0 is 1. Okay, so I'm going to go ahead and make a clarification there. So any x to the power of 0 equals 1 except for if x is 0. Okay, so I'll just do 1 or 2 of these. So this would be equal to, it doesn't matter that it's x. Just matters that it's to the power of 0, so we get 1 over y, and then again we should technically say where x is not equal to 0. And we'll just look at the next one. So simplify your term that's to the 0. One mistake people can make there is to simplify all that's a 1. That would be true if you had that, but you don't have that. Right, so that's 2 times x to the 0, or 2 times 1 over 7 times y, which would simplify to 2 over 7y. Okay, so moving on to the next example. What about negative exponents? So that is, you know, when I teach this to middle schoolers, when I was taught 7th and 8th grade, we'd say, you know, if you have a negative attitude, then your mom would send you downstairs to get rid of that negative, right? So just think reciprocal when you have a negative exponent. All right, so 5 to the power of negative 2 over 1 is equal to 1 over 5 to the positive 2. And then just simplify that to 1/25th, right? If you just punch that into your calculator is going to say it's equal to, 0.04. I think that's right, because that's what 1/25th is equal to, right? So do a little bit tougher one. So you could take care of your negatives first. I'll go ahead and do my subtraction first. That's the order I prefer there. So we're going to break this down to x to the negative 4 minus 6 times y to the 3 minus negative 8. So that's x to the negative 10 times y to the positive 11. And then we would simplify that to y to the 11 over x to the 10. Okay, and kind of another approach to that, if you prefer, is to get rid of your negatives at first. I don't really know why you would want to do that, but you could. So you could rewrite it without the negatives as, y, the reciprocal of 1 over y to the negative 8. To get rid of that negative would be y to the 8. And then you have the y to the 3 on top. And then if we send that one kind of downstairs, then you have over x to the 4 times x to the 6, which would get you to the same result. Okay, I kind of prefer this way, so that's why I showed it that way. All right, and then I guess our last rule is the power of a quotient. So this is just like the power of a product. Okay, think of it as the distributive property. If I have x divided by y, all taken to the power of m, then we just take everything to that power. All right, so in this case, we'd have x to the 5 over y to the 5, and then there's nothing else to do. You wouldn't subtract those exponents because x and y are not like bases. So then we'll just do maybe b and then call it a day. Okay, so if you can, I like to simplify first. All right, so I'm going to go ahead and simplify n to the 4 over n to the 2 as n squared. So then I have 5b squared, n squared, all raised to the second power. I didn't have to do that first, but I feel like that's going to save me a little bit of work, so that's what I'll do. So 5 squared is our coefficient, which is 25. B squared squared. That's equivalent to b to the 2 times 2, b to the 4. And then n squared squared is n to the 4. All right, so on that note, we'll just go ahead and finish there. Sorry for the length of this video, just kind of a lot to get through. And what I want you to do then, your kind of homework assignment, if you will, is the rest of this worksheet on your own. So it's on page 3 of the attachment there. You don't really have to print it out. I know some of you guys like to. And this is a little more application kind of stuff. So just try your best. It's a low stakes kind of thing. It's not really going to be for a grade, more for you to just do them. Try them on your own. Just do what you can. And then I will post kind of the answer key or the filled out notes, if you will, so that you can check your work that way. And this will really be helpful with the rest of the chapter. So make sure you do it. Make sure you ask questions if you have any. And let's just get this second semester off to a good start. Thanks for all your hard work. And like I said, let me know if you have questions. Y'all have a good one.